All right, hello everybody. Welcome to the course. Welcome to your first day of this semester. I hope you're all as excited as we are. Later on, the main brain behind this course, Kara, whom some of you have met already last semester, will join us. And today we have a big day. We have a lot to cover. We have a course intro, and we will have a guest lecture today as well. Do you see the same stuff? Yes, you do. Hopefully, at any moment, if you can't hear me, or if I'm not projecting my voice, or if you can't see whatever I'm referring to on the screen, please stop me and let me know, in case if I am not aware of that. Otherwise, again, warm welcome. As you already know, this course will be divided between Thursdays and Mondays. I will talk you through what we are going to cover on those days a little bit later. So firstly, I'm Christina. Some of you met me last semester. Cara will be joining us, and design systems. A bit of a step comparing to the last semester. First of all, I would of course like to acknowledge the traditional owners of the lands on which we meet today, and pay respects to their ancestors and their descendants who continue cultural and spiritual connections to country. We recognize their valuable contributions to Australian and global society. You will see this slide more times this week, I imagine. Moving on, learn objectives. So we have quite a lot to cover, and after completing the course, you should be able to demonstrate advanced understanding and application of creative problem solving. As in any other design discipline, it's all about solving a particular problem, development of critical thinking, and your research skills to answer project brief. I'll tell you even more. This course is quite a bit about research, so that's why the division into 2 days. One day will be more research-oriented, the other one a bit more design-oriented. Towards the end, you will have a bit more of design load compared to the start of the semester. So critical thinking and research, and a lot of it this time. Demonstration of leadership in the management of a design project through the application of appropriate methods, processes, and techniques to create a design outcome to a high professional standard. We will have deliverables that correlate with this objective. Critical reflection on individual design strengths, professional skills and attributes, and formative feedback to develop a personal design identity, practice, and portfolio, all demonstrated through your deliverables at different stages of the course. I'll talk about your assessment tasks in a little while. And communication with your peers. Communication will be through visual means, through presentation, through prototype, through many other means that you find appropriate, which will also need to be effective and professional. So whatever you're designing, you need to be able to explain it through various mediums and to explain your main design intent. A bit on teaching stuff. You will be mostly dealing with me when it comes to emails. There is my email over there. Please shoot me an email if you have questions, if you have troubles, if you have something you need an advice with. Otherwise, there is also Cara. Cara will be a bit busy this semester, so you can, of course, send Kara a message too, but I suggest sitting with me and I will try to take it to Kara if necessary. All right. So we have quite different degrees in this classroom. Some of you have different kinds of program. I'm not that sure if you have any kind of exchange student arrangement and you don't have the prerequisites. For those of you who have been here before, we have a prereqs for the course, so it's much easier for you if you have completed the other design courses. That should effectively prepare you for this semester. Without it, you might lack some skills that are crucial for the course. So this course considers the application of design in developing systems with far-reaching social and economic effects. And that's the awkward moment when I realize I should plug my laptop in, which I will in a second. So emphasis will be on creating opportunities for innovation. Learning will focus on skills of project definition, incorporating critical and iterative design processes, and open-ended thinking in unpredetermined problems. So again, iterative. I will repeat this word many times, iterative, guys. Those who know us know that's the only way to progress your design. No other way. You will be repeating things. You will be returning to certain questions about your design and iteratively implement changes. That will become frustrating for some of you who may not be that accustomed to the process. The rest of you will probably be fine with this because you know that's the drill. Students will present a major design proposal reflecting their knowledge and skills accumulated from prior studies. So whatever critical thinking, communication, even graphic design skills you have by now, those will come in handy. And of course, this time we will be a bit more research oriented. So in this course, we will have the opportunity to engage in this transformative design experience by presenting a major design proposal and showcases the knowledge and skills that you already have, hopefully, or will develop to some extent. And we're going to focus on a real life world problem with the general aim of fostering positive social change. So that's what the course outcomes are going to be about. And throughout the semester, you will actively participate in reflective activities, a lot of self-reflection, a lot of it. I mean, that's one of the ways to advance your design. And you should eventually be able to find your way through design, through the activities we offer you in the course, and through reflection on your design process. And as a part of this process, you will negotiate, scope, manage, and deliver on all aspects of a significant design project, leveraging the design methodologies, processes, and expertise required from your chosen major. And again, we will talk to you about various activities that should help you with that and about various methodologies that we will use in this process. And by the end of the semester, we should get to design a solid project. And that's your capstone design course. And this is a really good opportunity for you to demonstrate your ability to apply the knowledge and skills that you acquired in a meaningful and impactful way. This proposal should represent the culmination of your learning experience and highlight your ability to apply creative problem solving, lead project management, reflect on your design strengths, and communicate professionally. So that's the final course of the program. That's when you shine and show off all your skills. So you will need to approach your design brief, which we'll talk about a bit later, smart. Think about this project as the final big project you're making in the program. So you do want it to be as creative, as strong, as interesting, as indicative of your progress as it can possibly be. I just realized I'm not talking into my Zoom, which is probably a bit of an issue here. 1 second, guys. Oh no, maybe I'm fine. Sorry for that. So think wisely, choose wisely, talk to your tutors a lot. You will have a lot of time with your tutors. This course pretty much is based on you talking to your tutors. You will have a problem with plugging your laptop here. You will have 2 sessions per week. On Mondays and on Thursdays. On both days, you will have time. Well, not today because it's first day. We don't know what we are doing yet, but generally you will have time to talk to your tutors on weekly basis at least, hopefully twice a week, to discuss how your project is advancing. And that's the way to ensure that you're moving in the right direction. All right, so your learning objectives. Demonstrate advanced understanding and application of creative problem solving, critical thinking and research, to answer project brief, demonstrate leadership, critically reflect on your individual design strengths, show off your skills, and communicate effectively, as we all talked about it. This is the slide I will be showing you every now and then, pretty much every week. I will be showing you the slide. Also, all slides will be uploaded to your Ultra. If you also have an issue with Blackboard Ultra, welcome to the club. On a weekly basis, we will have your slides in your corresponding week folders. This week's will be open to you by the end of the session. And here is the overview of the semester. So we will have 2 assessments in the first part and a final assessment in the end. So 3 assessment tasks. 3 is a lot, but first 2 are fairly light, which is, I think, good news. So first assessment is due in week 4, 20% to be final grade, and that will be the affinity map. I'll talk to you about it in a minute. Assessment 2 due week 6, design brief, and final assessment in week 13. Again, everybody who has been in this school knows the drill. Week 13, design week, you have your final crit. You know about it, and this time it's going to be a hurdle. I'll remind you every now and then, but for now, hurdle is, it means that if you don't pass the hurdle, you don't pass the course. Even if your first 2 submissions were high 7s through the roof, if you manage to not pass the final one, that's unfortunately going to tank your grade to 3. That's not us being cruel, that's the school policy that we can't really avoid. I wish we could, but no. So please keep that in mind. I'm not saying you can safely fail first 2 assessments. Try not to, please. We are happy when you're happy and not failing, but you totally shouldn't fail the last one. That's the meaningful one. Now, about the course structure. As I mentioned previously, your workload is divided between Mondays and Thursdays. Mondays are more research-oriented, so you will be discussing your research findings on Mondays, and Thursdays will be more design oriented. So on Thursdays, it's more about advancing your design based on your research. So it doesn't mean that the two are disconnected. They are very much not. They are together, just a bit divided so that you can focus on one part of the project on Mondays and a bit more on the other one on Thursdays. But your research should drive your design. That's two parts of one process. Why? In part because we really want your design to be informed. We want you to make your design decisions and choices based on the information and analysis that you have conducted. So that's not something that lacks strength, justification, and rigor. That's why we have this much research in this course, so that you can explain in an effective way why you're making certain choices with your design and how you are solving the problem, and that you have examined the ways the problem was approached, the problem appeared, in order to make your solution as effective as possible. So that's what's important. And each week we will be sort of focusing on different topics of design and methods of research. Today we have an introduction. On Thursday, we will talk a bit more about design and complete various activities, which should be fun, hopefully. And yeah, we will be introducing different disciplines of design and defining it as we go. So you can see pretty much the overview of the course. Today's introduction and guest lecture, which should be the highlight of today for all of us, I assume. And then we will have your weekly activities, weekly lectures. We will mostly have a bit more lecture heavy Mondays and a bit more activity heavy Thursdays. So again, this means that we really need to be here on both days. Please don't skip lectures and activities and anything really. And pretty much that's how it's going to be. With most submissions, well, with all of them, in fact, you are submitting your digital version through the Blackboard on Wednesday by 4 p.m. So before Thursday. Make sense? As you normally do with all design-based disciplines in the school. I don't know why we have this practice, but we just do. So that's how it's going to be. Assessments. Finally, assessments. The slides will be available to you by the end of the session again. So you'll have them, don't worry. Also, you have an assessment summary already available to you in the Ultra, in assessment section, with pretty much the same information. So in week 4, assessment 1, affinity map, we'll talk about affinity map, don't worry. It's not that stressful. It's just for you to collect your thoughts together. Assessment 2 in week 6, design brief. With affinity map, you will present on Thursday. With design brief, you just submit it on Wednesday and receive feedback, but you don't have to present it. So that's somewhat not good news, but probably a bit easier for you and a bit less stressful. And of course, final assessment, assessment 3, 60%, that's your hurdle. You will have a presentation. We will have rehearsals for presentations. Again, those of you who have done design 2100 last semester, you guys know that we will have a full dress rehearsal in the end. And then you'll have presentation to some experts from the industry, which should also be a very rewarding experience. Any questions about your assessments so far? Nope. Okay, so 3 of them. 3. Just 3. Good if you don't miss any of them. If you have troubles with any assessments, please do let us know. That's important. Studio expectations. So we really expect you to participate in studio activities and discuss your thoughts with your tutors during tutorial hours. You're probably already aware that we have students from different backgrounds in this course, so it's good to discuss your thoughts with your peers as well. Very important to see tutors on a weekly basis. Don't hide from them. Your discussions and reviews are not affecting your grade whatsoever, but those discussions can have a very positive impact on your grade. Sometimes you are stuck with something, which happens with design. That's okay. Happens to everybody. Sometimes I'm not saying you exactly, maybe you're not those people, but it happens when if you haven't progressed much or produced a lot to show, the compulsion is to avoid the tutor because of the judgment and the gift of shame you will receive from them. Please don't. That's any discussion, any small thing to discuss about your project can have meaningful and positive impact on your progress in the big picture. So please fight the compulsion to not show up, to hide from your tutors. Just please don't. And of course, during those studio hours, you have a chance to discuss your progress with your peers, run your thoughts by other people, bounce your ideas off other people, even if they're not tutors, even if your tutor said one thing and your peer said the other thing, that's still a part of the process, and that still can be a valuable part of your experience and of your journey as designers. So please be here, be present. If you are comfortable, try to engage with your peers and run your thoughts by them if that's an option at all. Discuss. Discussions do help. Remember how I talked to you about the hurdle with your last assessment? It's also an identity verified assessment task. Again, not because we're mean and want to see your face, documents, fingerprints in the end of the course, not really, but that's the policy of the school, that one of the assessments is identity verified, which means there is a minimal attendance rate. It's called attendance, but we don't really mean attendance, we mean participation. So if you just show up and talk to nobody and then you escape, that doesn't really cut it. So it is not so much attendance, it's participation. It's about your progress, not about us ticking off your attendance on the run sheet. It's not that. So please try to be here, try to be present. 80% participation in studio activities is required. So if you fall under this number, we may request proof of authenticity of your work, which will bring me to my next point about documenting your progress. Please document your progress as rigorously as you can. That's when you will need a journal to reflect on your activities, reflect on your progress, write down some summary of your discussions with your peers and tutors, sketch your ideas. Sometimes when you write things down, even you can't come back and remember effectively what you meant by that. Because the thought, it was there and now it's gone, and you're trying to backtrack it, doesn't work, so sketch. but I sidetracked a bit, so that can be a proof, but try not to fall under 80%. And if we don't see you at least 50% of the time, it's unfortunately a 3 as the final grade for the course. So please come if you can. Otherwise, for medical reasons, things can be excused, but generally try to be here, please. We appreciate it. Assessment 1 affinity map, we will come back to it. Again, we will explain to you what affinity map is. We will talk you through the process of making one, and that's due in your week 4. As I mentioned previously, submission by Wednesday through Blackboard, presentation the next day in the classroom. We will discuss your affinity map later on after the guest lecture. Assessment 2, design brief. Don't have to present it. You have to just submit it through Blackboard. Again, Wednesday of week 6 by 4 p.m. And assessment, as I talked about documentation, please document everything. You will need it. You will need to include it. We want to see your process. We want to see when you thought alternative paths to your design and made a shift. We want to see why. So everything has to be documented as you go. Reflection on reflective practice. So you may wonder why we're asking you to provide your reflections on your activities, on your discussions, on your progress. It's an important skill for a designer to have. It's an important skill for various reasons. And this course is a good chance to practice this skill. So reflective practice allows you to critically evaluate your work, identify your ideas, and improve iteratively, as we talked before. So again, iteration and reflection, and a lot of it this time. And you will learn from your own experience, among other things. So take time to reflect on your activities, on your process, on your findings, on your analysis, on your research. And that should be one of the ways to drive your own design forward and to develop strategies to improve your skills. So we will be doing that quite a bit. Sketch as much as you can. And then finally, talking about assessments, final one, presentation. And when you submit everything, week 13, and that's a hurdle. So it's not just 60%, it's not just the weightiest submission, it's also a hurdle. Please make sure you submit this one. Again, we'll talk about this one a bit more in detail later on. Typically, there is a minimum expectation of your efforts per week and of the time you input into this course. It's a 4-unit course, it's a big one, so 20 hours per week, including class time. Yay! Only 13 hours extra and you're fine. It's a lot of your self-directed work. Late submissions. Different schools have different expectations and different processes for late submissions. Good if you can avoid penalty. So try to submit by the deadline. Those of you who have used our local resources know that sometimes it takes a while to upload a large file. Don't cut it too close to the deadline. So that's School of Architecture rules, also outlined in your ECP. If you have questions, please refer to your ECP. It's available, it's been published. All deadlines, all policies, all late submissions are there. Extensions. I do not approve them. Kara over there also does not approve extensions. We can't help with that, unfortunately. You need to submit your extension request through the form, through your portal, and the office on level 3 will handle it. We unfortunately can't help with that at all. So my UQ request, I believe it's called, that's how you submit extension requests if you need one. So also remember that you need to support it with documents. Sometimes it's a medical certificate, and it takes time to approve your extensions. So if you can avoid it, it's absolutely great if you can. And we have a maximum extension limit for the course, 2 weeks. Otherwise, it becomes not really feasible to handle that. So please keep that in mind when you plan your further activities. And we'll talk to you about plagiarism and integrity in a little bit. And I believe now it's pretty much time to introduce your guest lecturer. We are very lucky today because we have Dr. Murray Simmons with us, who will give you a guest lecture on design systems today, and that's a great way to kickstart the semester with something engaging. Murray, you good to go?
So we'll just take a 5-minute extra to the toilet and we'll just set up some. So back in
5 minutes break, and we will see you at 11:38 sharp. Thank you.
Don't see the Zoom invite.
I sent it to your email.
Which one? My UQ, my
Good question. I wish I knew.
I can't see it on any phone.
Let me check where the hell I sent it. I have one input in my thing here. I'll tell you in a second. It's your. I think it's your UQ one.
Okay, so I'm on the UQ one now, but I've probably got 3 different UQ ones. That's the problem.
Do you have the email? If you just go to your email, your UQ email, or you can send it like in any other way, your preference.
Yeah.
So do you have this one? Murray Simmons at uqedu.au.
Yeah, so I'm coming in on my student one, so my S something or other.
Okay, I can resend it there.
If you just send it to my S473368.
S473368. Is it like at UQ?
At
They change it like every year.
That's so frustrating for me. I've got like 3 or 4 different staff ones.
Yes. 473368 send. Okay.
So for some reason I'm not getting my slides coming up on here. We tested it yesterday, it worked fine. So
Oh, David, it's cooling down. When did it heat up?
and the microphone you want me to wear is
If you want to have this one, and you go. And it's getting there. Starting up, it says. Any moment now. That's not. Nope. Want to put it again?
Yep.
Maybe this one will be better. Sometimes
Yeah,
with
yesterday I was able
maths.
to do it
Here?
without that, but the other thing is I might need to go to show picture, duplicate.
I'm so glad you're here today.
Yeah.
Yes.
And then we go 5.
So recording this is that's the Zoom capability, right? Yeah. Good.
Yes, sadly we don't have the good. Sorry, it's recording. We don't have the good auto recording as in some lectures.
Perfect. All right. Thank you for making that break short. For those of you who don't know me in the room, I see some familiar faces. My name is Cara Wrigley. I'm the Professor of Design here inside the School of Architecture, Design and Planning. Welcome to Design Systems. I'm just going to do a short introduction today to our guest speaker. We're exceptionally lucky today to have Dr. Murray Simons in the room. Murray has flown up from Canberra last night for this presentation. He is an academic among many things, currently at UNSW in Canberra. He is completing his second PhD because one piece of torture is not enough. Complex adaptive systems is his field of expertise, and that is what today's lecture is going to be on. This is going to be quite a foundational lecture for the rest of this course, so please do pay attention. And I look forward to the next hour or so of the stage. Please make welcome.
And thank you for that. Not sure it's all true. Great to be here. Great to get to know you guys and to see some different faces to the students I normally teach at UNSW. This is, of course, a passion of mine, and I've been asked to come and talk to you about something which I think is fundamental to your course that you're doing now, noting that this is your capstone program, which is, of course, the final part of this course, regardless of whether you're engineering and you've got other years to go still. But for those of you who are actually finishing up at the end of this year, congratulations on getting this far. This is the opportunity for you to absolutely nail who you want to be in terms of taking the design concepts to your job. Wherever you go, whatever you do, you'll have that little piece of paper saying you've done a design course, but can you actually do it? Can you actually deliver and be able to stand up in a job and be credible and recognized and respected for what you bring to that conversation. Because if you're here to tick a box and get a piece of paper, this course is not the right course for you. This course is going to stretch and challenge you. It is intended to because it is a capstone course. The assignments that have been outlined to you already are fundamental in giving you not just the knowledge, but the internal character traits of someone who is exceptional in design. And this is such a cool place to be. This is such a cool course to be doing and such a great opportunity for you guys to actually have the chance to develop those final skills to hone your expertise as someone who brings design, either as an architect, as an engineer, or whatever field you come from, and how are you going to deliver that? How are you going to be recognized in your profession for who you are? This is the sprint to the finish. This is the cool part. You're turning the corner on that racetrack and you can see the finish line. This is exciting. I think it's exciting. You guys, of course, have got your own journeys. You'll know how you want to have that story unfold. So, one of the things about this course is that it talks about systems. So, there are many types of design. You will have explored and talked about different ones along the way. What sort of design thinking methodologies or design types are there out there that you've come across? I'll give you a hint, this is going to be interactive. If you think sitting there not answering questions, you're in trouble because I'm the sort of person who walks around the room and I will say, yes, please. Industrial design, excellent, good, there's one. Graphic design, excellent. Yo.
User interface design.
User interface, ooh, nice. You're doing an app for your final design? Nice. Maybe, yeah. Product design, good. Any others? Service design, yes. See, your lecturers are so excited to know that you remembered environmental design, cool. What else we got? The rest of you haven't answered yet. The lecturers are looking at you going, were you sleeping? So I'm like, cool. How those new ensembles? That's good. Not the arrow sitting behind you before. What else? Yes.
Systems design.
Systems design, correct answer. Good. And so what you'll see here on the slide is a selection. But I've kind of drawn out the systems design because there's a whole bunch of subcategories within those. And so obviously the session here is talking about systems design and what it is that we're talking about when we get into system design and how will it affect both this course but your final assignment.
We have a Zoom thing.
A Zoomy thing. There's a Zoomy thing going on, that's right. We're just going to make a Zoomy thing happen.
You keep going.
No, well, I don't know what to say. The pictures kind of tell the story. So we have systems design. There are a number of subsets. There are a number of reasons why systems design affects what you will be doing this semester. No matter what the topic is that you choose for your system design assignment, there is going to be an element of methodologies and systems that weave into it. So whether you're doing an app or whether you're an engineer and you're making widgets and product design, systems awareness, or sometimes called systems consciousness, versus systems shifting. And these are the two concepts that this session is going to explore and unpack today. Once we get our slides up and running.
For 1 second, Mari.
Okay, you know what you're doing. Who likes Zoom? Who uses Zoom? Who has to use Zoom? Is Zoom a system? When we've got lots of people on Zoom, are they representing a system? What is a system? What is not a system? Who enrolled in a systems course expected to be told what a system is? Who turned up today going, oh, that's right, the lecturer will tell me. I'll just sign up for a course that I had no idea what it's about, but I'm sure they'll tell me when I get there. This session is going to go through systems theory, and it will give you an insight into the different types of systems that we're talking about and how and why they apply for you in design. We're going to have a quiz. There will be an exam. You will be expected to pass the quiz. This is an interactive session. This is not one of those sit there and be on your phone and do other things. It's about watching, learning, thinking, and interpreting in your mind how it works. There's a thing with the commandment framework. Has anyone heard of it? So I've been asked to talk about that as well. So we're going to have a bit of a yarn about what that is and how and why it influences what you do and how you become not just an average performer, but an exceptional designer who is proud to wear the badge of being a YouTube graduate. And the brand reputation of YouTube will stand on your performance in the workplace. And we'll finish up with a bit on systems shifting. We'll have a break in the middle. We can recharge because there's a bit here. All right, so first question is, what is simple? What does it mean to be simple? What is a simple system? You might need to be in a position where you can see what's going on here. Anyone allergic to eggs? Anyone allergic to eggs? I did this one time. It's an anaphylactic student in the class, but all good. So I need a piece of paper. I don't want to make too much of a mess here. What would happen? You sure? Let's see. All right, so if I have an egg and I have a hammer and I hit the egg with the hammer, what's going to happen? You right? Not sitting too close? Do you want to do it? No, come on, you do it. Come on, do it. Come on. You don't want to hit it?
I don't want to.
Oh, yeah. Excellent. Ladies and gentlemen, we have a volunteer. Someone who I can chop in half later, thank you. Ready? Watching closely? Ah! No way. Grizzle. Thank you. So, we have an egg. Think quick. Hey. Thank you. Ready? Catch! And cover! All right, so the point about this is that right now, right here, you have made assumptions about what will happen when you hit. Not get anyone? You don't let you have it. You know that an egg will break when you hit it with a hammer. You're working on assumptions. These assumptions give us what we call mental models. Mental models are what trip us up when we're in systems design thinking. They are the things that we assume are true, but aren't because we haven't bothered to do our homework. And for your assignment that you're going to be doing for this course, and dare I say it, for every other thing that you do for the rest of your professional career as designers or people who have design in their degree, it's about going beyond those mental models and making sure you have cross-checked exactly what it is that you're making assumptions on. Does this make sense? Anyone confused? Wait till I get to chopping people in half. That comes next. Right. So, simple problems have two parts, and their outcome is known and predictable. And so we end up with a situation where things like engineering or so forth, there will be a cause and effect relationship which is known and predictable, and we know how the answer ends. Because we know that when we throw an egg at somebody, it's going to go squash. Make sense? You scared yet? Yeah, you shouldn't be in a front row seat. All right, complicated, on the other hand, has more component parts. So simple has two parts, and their relationship is known and predictable. The more parts we add, the more complicated it becomes. What's the difference between complicated and complex? Who uses the words interchangeably? Who thinks they're kind of the same thing? Who goes to the student bar and uses the word complex and complicated interchangeably? Tell you what, when you're at the bar and your mates talking complicated and complex and they get this wrong, don't correct them, right? Because you just don't want to be that person, because that's a bit nerdy. But there is a very different term for each, which we use, which have a very fundamentally different meaning, which is really important for you as designers to understand. And for your assignments that you'll be working on, I'll give you a hint. Complicated is the easy stuff. Complicated are things like jet engines. The jet engines have multiple parts, and they're connected in a way which the outcome is known, and the jet engine will work each time provided the systems are correct and put in place. And we can take out the fuel pump, or we can take out a part, and we can replace that individual part of the system, and the rest of the system will not be affected. Does this make sense? The more parts, the more complicated. Less parts, less complicated. It just refers to that predictable known outcome. So anything that's got a Gantt chart, flow chart, What else have we got? Chemistry formulas, physics, maths, coding. What else have we got there? Some logic. We've got recipes. We've got cooking. We've got how to fly an aircraft. Flying an aircraft is only complicated. Anything that a computer can do means it's complicated. If we can have aircraft fly by themselves, UAVs, for example, it's a complicated system. Driving a car, is that complicated? Can we have self-driving cars? Can a computer do it? Is it something predictable that we can write a formula for and have a machine do it for us? And if the answer is yes, it's only complicated. And ladies and gentlemen, if you're only doing complicated stuff, you're not actually being stretched. Now, to be kind to the engineers, and bear in mind that I'm actually a science maths teacher in secondary school in my other job. It's not that I don't like STEM, but STEM is complicated, particularly at the undergraduate level. Once we get into quantum physics and a whole bunch of other really cool stuff, PhD level, it starts to become a little bit more complex. But ultimately, anything where the answer can be calculated with a formula and it's a known relationship, it's only complicated. And what we're talking about today is going beyond complicated, we're going to complex. What do you think complex might be? Yep.
This is where we don't know the outcome.
Nice, yep, good, where we don't know the outcome. Bear in mind that some mathematical problems we don't know the outcome because we don't have enough information yet. So don't confuse not having enough information, so you still need to go and find the variables or the unknowns, but once you've got them, you can still solve it, yep. Complicated, A to B is predictable. Complex, A to B is not known. Complex is something like social network analysis, or if you think social media, you think of the interdependencies, you think of things like stock exchange, you think of the weather. These are things where the relationships in between all of these nodes, as we call them, there are so many of them, it's like looking at one of those spider web nests, all little baby spiders in it. It is just so intertwined that when you affect one part of it, it has a second and third order effect that cascades across that is not possible to predict because it is so dynamic. And so what we end up with is like a half-inflated balloon. When we squeeze part of that balloon, it alters the system. Anytime we make an influence on it, it changes the system. The system is never the same. Social media, social influences, as soon as someone posts something, it changes the system. There is no A to B, there is no relationship which can be predicted in terms of how something might go viral or not. You understand what I'm saying with social media, social influences, that kind of thing? All right, so we have all of these things going on. What can you see in the picture? You can see something in the picture. Yep.
Right, you can see a face.
Nice, you can see a face. Anyone know whose face it is? Marilyn Monroe, good. Okay, so the further away you are, the easier it is to see. Does that make sense? If you stand too close to it, I'll use this one here, but imagine I've got a little toilet roll tube and I'm looking through this part of the system, which you can do with a complicated system. You can change the tires on a mountain bike from slicks to knobblies and the rest of the bike still works. It's complicated. Here, if I look at this part here, it does not help me understand the whole system. To understand the system, we have to look at it holistically. We need to step back from the picture and we have to see the Marilyn Monroe. That's a useful phrase to remember because when you're working with your assignments and you're dealing with complex adaptive systems, you need to step back, and if you cannot see the Marilyn Monroe, you're standing too close. In other words, you're looking at a piece of it through a toilet roll tube as if you think you're going to understand. Here's a different example. Here we have some ants. And we see complexity in nature a lot. Ants, on their own, are not intelligent. You cannot take one ant and put it under a microscope and study it and understand how the intelligence of an ant colony works. Here you see the white ruler moving further and further out as the scientist experiment goes on. The ants are working together collectively as a system to fix the issue of the gap between white and white. They are operating as a complex adaptive system. They are adapting the outcome to how and why they do what they do. The same thing works with an intruder going into, say, a termite mound or into a beehive. The rest of the bees will come in and adjust and adapt to that intrusion. So what we have are self-stabilizing influences. The animals want to restore their colony back to the way it was beforehand. This is one of the two key features of a complex system, that's the system, what we call status quo ante. So the status quo before the intruder came into the termite mound is what the termites want to restore their system back to. They kill off the intruder, the snake, or the spider, or whatever it is, and then the whole colony goes back to normal. There is another variation which is called status quo nova, which is the new status quo. In other words, it stabilizes it at the new state. So a mouse gets inside a beehive, really cool. Bees actually kill off the mouse, but it's too big for them to eject out of their head. They actually have this really cool thing which is like embalming, and it kind of stops the thing rotting and going all yucky because they can't. Anyway, they are establishing a status quo nova. So they're establishing a new normal with this dead mouse in their hive. Yeah, you can get rid of it. Emergent is the other property. Emergent is when the system keeps changing over and over. And so the self-stabilizing influences are decreased in terms of their influence. And instead of restoring the system back to how it was, the emergent properties are actually causing the system to continue in a new direction and constantly evolve. Make sense? Any questions so far? Anyone confused? Am I talking too fast? I folded around. I forgot to tell you I'm not a psychologist, actually, like that. Make sense? All right. So we would often represent a complex adaptive system with what we call a social network analysis or a affinity diagram or a whole bunch of graphics. Anyone here using NVivo? So something that comes later, they don't use NVivo. Okay, so NVivo is one of the software packages that we have which help us make sense of complexity. It helps us load all the data in, and it kind of comes up with graphics like this for us, and it helps us make sense. Is that a question or is that a sorted? All right, so we have these things here which look like this, and you can imagine doing your circle of friends or your Facebook, or you probably don't use Facebook because that's old people stuff. What do you guys use? Snapchat, I don't know. The Gram. What else am I missing out on here? Insta. Anyway, whatever. You could draw a circle of your group of friends and how your network kind of unfolds. When we get more and more complex, we get more and more stuff in there, it becomes incredibly difficult to comprehend. And again, we're talking about some of the projects that you will choose to do for this assignment, for this very course. Because regardless of whether you're doing product design or you're actually getting right into systems thinking, either way, everything is interconnected. If you're making a new phone or a new app, you've got to consider your customers. If there's humans involved, it's complex. And if it's got an element of complexity, you're thinking about the end user, you're thinking about the people who have to make it, you're thinking about all of the other things that are all interdependent. Fashion. How dynamic is that? All right, so I haven't got time to go into this, but the point is there's a whole bunch more literature on all of this stuff. These are some of the things that we talk about for those who really nerd out on complex adaptive systems and what we refer to as self-stabilizing influences. These are the types of things within a system that will influence. So if you're going to go down the path for your assignment to look at something like, I don't know, well, any of the things which happen to impact on society, such as rural health, human trafficking, domestic violence, any of these things which in society we're trying to resolve and fix, or if you're into NGOs and you're looking at traveling the world and you're wanting to make the world a better place, then knowing which of these things and how they influence a system are really useful for you to unpack and go deeper on. So I'm not going to go into them now, but if you're interested, you can see me at the break or afterwards, and I can give you lots of resources, or you can Google them. So, antibiotics are a good example of a self-stabilizing influence on your body. When you take antibiotics, it's killing off the bad guys and leaving the good guys there. Make sense? Sometimes it kind of kills off a few too many of the good guys, right? You know what I'm talking about? Anyone here taking antibiotics? What do you take afterwards to kind of rebuild the good guys? Probiotics, good, nice. So what we're talking about primarily though is the stuff that restores a system. We can think of an example of a self-stabilizing influence in our society. Okay, let me take you to, say, conflicts around the world. Look at the countries which control social media and lock them down and don't allow their people to be able to use certain social media. Or they have moral police that go around with batons. Or you look at the police, or you look at traffic lights, or you look at speed cameras. All of these are self-stabilizing that cause the system to retain some sort of control and order. Autocratic nations are more likely to have a lot more of these. They're going to have cameras watching everybody. They're going to have a whole bunch of things which are designed to control the population and to keep it from being adaptive. Think of the Arab Spring, I'll be going back a few years for you guys, when social media allowed people to talk between themselves and allowed them to overthrow what the government was trying to send as their message, simply because they had the opportunity to communicate between themselves. And so a lot of the countries kind of realized social media was a bad thing for them to be able to control. So, all right, here's a question for you. If you haven't seen this before, what is the number underneath the parked car? Yes. 87 is the correct answer. 87 is the correct answer because, well, actually more the reason I like it is because you have to turn the map around to solve it. You turn the map around by tipping the picture upside down. As soon as you tip it upside down, the answer becomes more obvious. Your ability to think around the corner, your ability to turn the map around, as we say, to turn the problem around, to use what we call reverse thinking, to ask the questions no one else is asking, that, ladies and gentlemen, is the secret to you cracking the code on how to influence complex adaptive systems. And so we end up with a situation like this, where when we look at it from a different angle, we look at it through what we call personas. You guys covered personas yet? Personas covered? You know what we're talking about with personas? Personas are the things that we use to look at the situation from different people's perspectives and make sure we've explored it so we can see the Marilyn Monroe. We're not looking through a toilet roll tube of our own perception of what happens when someone throws an egg at you. We need to ask what else is there. So who would rather be smart? Who would rather be intelligent? Got a few intelligent people. Any for smart? Who are brain dead and thinking about footy or I don't know, whatever, Instagram. I shouldn't have said Instagram. Now you're thinking about your Instagram friends. So no one wants to be smart. Okay, who can tell me the difference between being smart and intelligent? Well, like complicated and complex, we use them all the time. Yes, good answer. Yes, thank you. What's the difference between smart and intelligent? Never scratch. Never make eye contact with the lecturer either. Note to self. If it takes you till third year to work that one out, it's a problem. All right, my students in the NSW have learned not to make eye contact with me because I'll pick on them. See how it works. All right, so smart and intelligent. Intelligent and smart. Smart is kind of the person you want to have in your pub quiz night because they remember all the facts. They know all the data. They've got great memories, but often they don't actually know how to use it in the right situation. So you might say someone's a bit of a smart ass or something. You might say, yeah, you're right. Technically, that's correct. But in this situation, it doesn't apply. You know what I'm saying? They're smart. They know lots. Really, really, really good memory. But how and why do they use it in the right time? Intelligent is all about pattern recognition. And if you've done IQ tests, intelligence quotient tests, you will know that it's about pattern recognition. And so you're trying to work out what's the missing square here. And of course, they do them at speed. And your brain's going boom, boom, boom. And you're looking for the pattern. And your ability to recognize patterns determines how intelligent you are. Because that's how an IQ test works. Well, guess what, ladies and gentlemen? Being intelligent is not what we need in our designers. If you want to be intelligent, you probably should be over in engineering. Oh, you guys are engineering for that now. So engineering is great for pattern recognition. It's good for complicated problems. But design methodologies and systems design is about going beyond intelligence. It's that reverse thinking. It's about thinking of it from different angles. And dare I say it, what I have given you here is a false dichotomy, which is giving you two options. As soon as the system tells you, oh, you've got to pick between one or two, the correct answer is neither. What you should be saying is, I want to be an anticipated genius. Because anticipated geniuses are able to look forward, not backwards. This here is looking backwards. It's looking at a current situation, looking for the pattern and going, oh yeah, I can see what the correct answer is next. Make sense? Your ability to deal with complex adaptive systems means going beyond intelligence. And in fact, often intelligence is actually a problem. So people who are good at intelligence are often struggling to deal with complex adaptive systems because they're looking for patterns. So there was a drunk guy rolling around on the ground somewhere around here, using the spotlight for the video benefit and for the people down the far end. But he's bumbling around on the ground, and a lady walking past goes, well, what are you looking for? And he goes, oh, I dropped my keys. And she says, where did you drop them? And he goes, oh, up the road up there. She goes, well, why are you looking here? Because that's where the light is. Ladies and gentlemen, we too often want to look at where the light is because we think that's going to tell us the answer, when in fact the real answer is not where the light is shining. You understand what I'm saying? Don't be seduced into looking at stuff simply because there's a number on an Excel spreadsheet. What we really need to be able to do is go beyond the self-stabilizing influences, because the complicated part of a system is the self-stabilizing. They are the bits that are easy to do. That's what the average people are doing. Not you people, not graduates of design courses, but people who turn up and just follow the bouncing ball, learn a formula, Bernoulli's theorem or whatever, put in the data. Yeah, well, once upon a time you used to be able to do that all by hand. Now you put it in the computer. Excel spreadsheet can probably do it for you. They're the people that are not going to have a job in a few years' time. Being able to go beyond looking where the data is showing the pattern is what really is important. So we have this continuum that goes along from where there is light in the system, which is the patterns, which is cool, that's nice, sure, we still look at that, but it's the teeth of the dragon. The teeth of the dragon is the emergent part of the system that will bite you. They are the bits that no one else is thinking about that you need to ask questions on for your assignment in this course, but beyond this course. Because this course is not just about getting a mark, it's about being the best designer you can and about asking those questions, reverse thinking, looking for the anti-patterns, asking what will go and bite you because it's not the obvious thing that everyone else is looking at. Any questions so far? Am I talking too fast? Sorry. All right. Who knows about survivorship bias? 1, 2. Oh, do you want to tell us?
The plane was safe because I didn't crash it.
Ooh, nice. Okay, I like that. Yeah, that's a good way of putting it. It comes from World War II when they got a whole bunch of really clever mathematicians and scientists and boffins and engineers, and they put them all in a room. And for a couple of years, they collected data on every bullet hole of every aircraft that came back from a bombing mission to work out where all the bullets were falling, because they can't armor plate the entire aircraft. And they thought, well, if we work out this, we'll just put armor plating on the bits where all the bullets fall. How cool is that? Great engineers. We need more engineers. Any engineers in the room? Oh, yeah, one very person says it's What's the problem?
I weren't accounting for where the ones that didn't come back.
Boom. We don't care about the ones that, well, we do care. But from their perspective of fixing aircraft, the ones where the engine are or the pilots are, they're the aircraft that didn't come back. The question is not where are the bullets, but where are the bullets not? We need to ask the questions that are not in the pattern, that are not obvious, what we call spaces between the cases. It's the dragons, ladies and gentlemen. If you're not hunting dragons, you're not doing it right. I happen to be a passionate dragon slayer. These are some of my journals. It's book 89. Traveling through the Sahara Desert earlier this year on camels, looking for those dragons. I've actually covered the picture up, but behind there you can see my boot. This is me in Lebanon at a cool monastery where the feet from St. George and the dragon actually was slain. Oh, anyway, we digress. The thing about dragons, though, before you can slay them, you've got to find them. You can't slay the dragon if you don't know where it is. And that speaks to what are the things that are not in the patterns. And the challenge is The dragon's on the move. And I give you another hint. It's not a dragon, it's dragons. And you got to find all of them. And they're all on the move. And they are adapting and evolving so that what worked last time won't work next time. Make sense? We're going to stop for a little bit of a stretch. A couple of minutes. When we come back, we're going to talk about complex wicked systems. Any questions? Your time starts now. 20 past, back in. And take a screenshot. And so what we're talking about here, frozen. Who recognised the music? Frozen. The real world is not frozen, ladies and gentlemen. The real world is constantly in a state of flux. What we have, and I haven't got a silk scarf to try and show how this works, but imagine this with a silk scarf, and I am fluttering it. It is constantly moving. But that is only a two-dimensional picture, because in reality, we're talking three-dimensional. And so what you see here, the fancy word we call it is synchronic. Synchronic is a screenshot of a system, screenshot of a complex adaptive system, frozen in time, and you can study it. And that's great. We let them in. What do you reckon they're late? You have to play it coming out. So synchronic is a screen capture of a system. The reality is the system is actually diachronic. The system is actually we stop. And when we stop. The real world is actually constantly changing. Whatever it is that you choose for your assignment, whether or not you are making some whizzy-do new product design from engineering, which is actually complicated, it's interfacing with humans, and the humans keep changing. That is why we use the word diachronic. There's also polychronic, monochronic, but don't worry about all that. Diachronic speaks to the fact that the system is constantly in a state of flux. Make sense? Your staff on this course have been very, very generous. I heard a whisper that they're going to allow you to treat the system as synchronic for the sake of learning how it works. In reality, when you get out to the big bad world where the dragons are, it's going to be a diachronic situation. You're designing some new fashion item, fashions change. It's constantly in a state of flux. Your ability to produce the next coolest handbag or dress or whatever it is that you're designing is going to be at the whim of the system, which is constantly in a state of change. And that's actually a two-dimensional picture, but I've actually shown it as a four-dimensional because time is the fourth dimension. But if you want to get really sophisticated, it goes up to 9 dimensions. And you can talk to your mathematicians in the class. And that is the shape of the curve, which your blanket looks like when you're trying to find the corner at 3 a.m. because it doesn't seem to have an end. That's what the real world can be like sometimes. So we then get into another type, which are known as complex problems. Who has heard of a complex problem? A little bit of sound life. Cool. Who hasn't answered the question? Do you want to tell us what a complex problem is? Was that complicated or simple? What's a simple problem? What's a complex problem?
There's like lots of different factors that you need to consider, and they're always changing. So like for example, like this more like lack of real there is a problem.
Nice. Excellent. And that's exactly what they'll teach you in most courses. I'm going to go another step beyond that. Picture I have up here is, does anyone recognize the picture? Anyone from Sydney?
Manly.
Manly. Nice. So North Manly Beach, South Manly Beach, Far End, South Manly Beach. Back in COVID. Anyone remember this thing called COVID? From your school, whatever. All right. So the very first case of COVID in Sydney was some dude who went and sat at the southern end of Manly Beach. And by golly, that sent a whole lot of problems for the LGA, Local Government Authority, because they went, chicken little, the sky is falling. We have a COVID case in Sydney. Do you know what they did? They closed South Manly Beach. They said, no one's allowed to go to South Manly Beach. That's it. That'll fix it. We'll fix this problem. What was the problem with that? Well, you're not at the beach anymore. That's a good point. Yeah. But the southern end of South Manly Beach is now closed. So no one's going to get COVID, right? Where did all the people go who used to go to South Manly Beach? Yeah, they went to the other end of the beach. They all just squashed in up this end. And then they went, oh, that didn't work. Oh, okay, we're going to close all of Manly Beach. That'll fix it. No more COVID in Sydney. Did they get it right? Did COVID ever come to Sydney?
Sure did.
I was living in Coogee over on the other side of the harbour bridge. And guess what? Everyone on all the beaches were like, woo, let's go to Coogee for the Sunday afternoon play at the beach. More and more people were getting compressed into fewer and fewer beaches, which actually made COVID worse. Suddenly the LGAs went, oh, this is not a complicated problem. We can't switch 1 to 0. Switching 1 to 0 is what engineers, mathematicians, scientists do when they go, oh, we need to study this variable. We'll switch all the other variables from 1 to 0. In other words, we make them constant, and we'll just study that one thing. The LGA, the Local Government Authority, thought that turning off Manly Beach was going to solve the problem because they were treating it like a complicated problem. In fact, all of Sydney is a system. And the people responded like that half-inflated balloon, and they changed and adapted. And suddenly all the LGAs had to get together and go, you know what, we need something for all of Sydney. Make sense? Did you have something like that up here? Different LGAs? So we end up with not a problem, but a system. There is a difference. A problem can be solved. A problem has an answer. A system cannot be solved. You cannot use the word problem if you're talking about a system. For the same reason, you don't solve the stock exchange. You don't solve the weather. It just continues to exist. What we can do is influence it, but we can't solve it. And so therefore, it's not a problem, it's a system. Is a Rubik's Cube simple, complicated, complex? Who's done a Rubik's Cube? Anyone remember Rubik's Cube? Probably before your time. Anyone remember their grandfather? What's a Rubik's Cube? How does it work? Yes, it's complicated, thank you. Because, can you get a computer to solve it? Can you follow a checklist? Can you follow a flow chart? Boom, it's complicated. You can even get ones that actually solve themselves, a little built-in motor inside them. But ladies and gentlemen, have a look at the dots on this one and imagine that every time you apply a turn on the dial, the colors on the dots change. Because every time you influence the system, it changes the system. You turn one side and the colors change on the dots. That, ladies and gentlemen, is a wicked system. And that is what the world will be expecting a graduate UQ design course to be able to deal with. It's when you as the decision maker become part of the system. You are now influencing the system. And so what we find is, as soon as you engage with that system, it changes the system. And if you know anything about wave-particle duality and the difference between when we observe something and when we don't, and if you're into researching, you'll know about the Hawthorne effect, which means that when we go and observe a bunch of people, if I was to turn up here with a clipboard and watch how you're learning, you'd start behaving differently. It's one of the dilemmas we have when we have to get ethics approval, because ethics go, oh, you've got to tell them what you're watching for. Oh, I'm going to research whether or not people wearing white shirts in class actually study better. That's what I'm looking at. Now, what are you going to wear today? Oh, see how we influence the system by actually being a part of it? As soon as you interact with it, you've changed it. The system is no longer the state it was. And it doesn't even have to be that you are actually doing anything. You can even have the ability to do something. If bad guys know that there are cameras watching them, or might be watching them, it's going to stop them doing bad things because the potential for them to do it. Before Trump was even sworn in, after being elected in that month or whatever, he started telling people around the world what he's going to do to the Russia-Ukraine situation, the Israel-Palestine situation, and that already started to influence the actors in the process because they knew that he had indicated his intent. And we often see, like tariffs or whatever, an intent to do something already alters the system before the tariffs are even brought in. Does that make sense? So it's not just actually doing stuff, it's the potential to do stuff that can change it. And about etiology, that's a fancy word for cause and effect relationships. It gets better. You thought wicked systems were bad. Here it goes more exciting. What we have is complex adaptive systems, which is what we would refer to as a complicated problem under the previous definition, because it just means things are constantly changing. What we have is complex adaptive systems. Within those, we have complex wicked systems, which is where we are influencing it. And then there's this other layer inside, which is called a complex adversarial system. And this is where the system is actively trying to destroy you or degrade your ability. So in the corporate sector, in market design, you've got competition between different other people making the latest dress or handbag or smartphone or app on the phone. They are trying to compete against you. They are putting in interventions that are going to undermine your intervention. The design you come up with is going to be actively targeted by being better by somebody else. There are systems, nodes within the system that are actively trying to reduce your influence in it. Does that make sense? This is the world that you're going into. This is the world of commercial competition. And this is the world that we expect graduates of this institute to be exceptional as being designers in an environment where every time they come up with a new idea, it changes the system and our competitors will outsmart it. That's the world you're going to. Oh, sure, you can make little kind of small things. You can be an average performer. But if you want to be someone that they write songs about, wow. All right, ready for the quiz? Stand by. 30 seconds. It's a closed book exam, by the way. No looking AI, no ChatGPT. All right. Is it simple, complicated, or complex? Feel free to call it out. Simple. 2 parts. Problem is fairly obvious. You know how to fix it. What about this one? My daughter going to Wollongong University. Kick-ons. 3 in the morning. Anyone been to kick-ons? Yeah. She thought this was a great idea. How does that story end? Yeah, okay, don't do that, by the way, just for the record. Delete that from the video. So, simple. The outcome is going to be predictable. What's this, a game chart? Is that simple, complicated, complex? Complex wicked, complex adversarial? Who's done project management? Yeah, good on engineers, cool. All right, if a computer can do it, it's complicated, right? It's just, now the reality is, of course, we've got humans in here and it starts to become complex. So what looked complicated is actually potentially going to be complex because the humans don't turn up, or they come late to class, or they go and get a sandwich and they don't come back. Or they think, oh yeah, that's better. Hetero won't notice. I'll just sneak in the back of the class. That's how it works, isn't it? Where's the self-stabilizing influence? What would the lecturers do if they didn't want people to sneak up and get a sandwich and not come back on time? Would they bring in rules? Would they put in punishments? Gosh, you get fun coming up with all the self-stabilizing influences the university puts to make you learn, like grades and attendance registers. Is that a self-stabilizing influence? All right, chess. Complicated, complex, complex wicked, adversarial. It's complicated. Why is it complicated? Because you can play a computer. A computer can play chess. The number of moves that each piece can make is a fixed outcome. It is possible to map every single move every stage of the game. And a computer can come up with its own ideas. The difference, of course, is the speed of winning, because a computer doesn't necessarily know how risk-averse the opponent is. And by testing the waters earlier in the game with pawns and things, you go, will they sacrifice their queen if I put it here? You've got a competitor who's actively trying to destroy you. If all you were doing is moving your pieces around on the board, life would be great. But they're trying to take your pieces. How dare they? How inconvenient. Maybe chess is a bad analogy. Does anyone know about chess? It was so pre-social media, wasn't it? Hey, nobody plays it anymore. Oh yeah, what about traffic lights? Surely somebody, anyone drive a car? Anyone go, yeah, silent life, good. Excellent. A traffic light, simple, complicated, complex, wicked, adversarial, wicked. Simple. Why are they simple? Boom, there's a fixed number of outcomes. So, yep, red, orange, and green. But in terms of the traffic, like when does it go red? When does it You ever been to those roadworks and they've got those little temporary ones on a trolley or a trailer type thing and it's on a timer and it's just like 1 minute, 1 minute, 1 minute? That would be simple. When we start getting to having a little bit more sophistication, you've got multiple roads coming into the same exit, you might have a crossroads, it starts to get a bit more complicated because there are multiple variables. Make sense? What about you're coming from a road that's not used very often? What do they put on the underneath the road in the car seal?
They take into complexity by knowing where cars are.
Boom, nice. So you run over the little sensor, it triggers, hey, there's a car waiting on the side road that's not used very often, then insert it into the system. Is it starting to become more complex? Is it still complicated? What about it's Easter and everyone leaves Brisbane and goes away on a big holiday, up the coast, down the coast, whatever, and they're all coming back at the end of the holiday period, and the traffic is a nightmare. Oh, what do you pull out of your pocket? You already got it out. What are we looking at on our phone? Yeah. Google Maps, Waze, or iMaps, whatever. They are looking at all the traffic, and they're going, oh, big red line. What's a red line mean? Bad, traffic jam. And it says, but I got a faster way for you. You turn off at this next intersection, you go through this little rural town, and you go past the little leafy suburbs where there's a little old lady out on her rocking chair, never has a car go past all year, and suddenly there's all these traffic going, you know what I'm talking about? Google Maps is altering the system. It's changing our behaviors. It is influencing based on information of the system. It's that half-inflated balloon. It is turning what was a complicated system into a complex one. And so increasingly now we're seeing traffic flows. In Brisbane, they have traffic kind of move from one end of town to the other, up and down the river. They have the traffic lights in sync. You know what I'm talking about? That's not life. Okay, it's getting late. All right. What else have we got? Traffic lights being connected to the AI algorithms for Waze and Google Maps, and they know when there's a surge of traffic, or when Suncourt Stadium's about to finish a game and there's going to be. It knows things in advance, and it starts to become AI enabled. All right. So just summarize on systems. What we have is simple to complicated. You kind of know about this already because we recapped it, but 2 pieces of Lego, simple. The more pieces you add, it becomes complicated. But Lego will never be complex. To be complex is not on the same continuum, it's not on the same axis, it's on a completely different axis, so X and Y, interdependent, all the way up to independent, where one influence on one part alters the other. Make sense? Happy with that? All right, there's a third dimension which you're aware of as well, which is the difference between self-stabilizing and adaptive or evolving. So we have our police officer out there with a speed camera, a self-stabilizing influence on the driver behavior. At the far end, I used a bunch of teenagers for fashion or whatever. They are constantly changing. What was sick last week is now no longer sick because that's so last week. I mean, what's the new sick? Is it still sick? Who still says sick? How do you know if you actually got the flu or? Yeah. Anyway, so your fashions, these things are constantly evolving. This is that diachronic system which you are developing things to work within. Either you're doing the latest app or whatever, which interfaces with humans, or you're actually changing the system of humans itself, like rural poverty or whatever. Some fancy words, post-positivism and positivism. If you're uber nerd and want to get into this a bit more, science versus art, it's dynamic, it's fluid, it's constantly changing. That is the true essence of a great designer. All right, here's the dots. You can see the little globes, the little yellow balls there. They indicate part of the system which is either more complicated, more complex, more adaptive. When you look at something, you go, is this complicated? Is it complex? But here's the exciting part. Watch the dots. Watch the dots. They're constantly moving. What was complicated in the morning becomes complex in the afternoon. What were simple traffic lights and now complicated, suddenly they were a complex system, and I'm talking about the traffic flow, not the actual device of traffic lights. And up in the top corner shown in red. This, ladies and gentlemen, is the essence of what you want to excel in. All right, we're going to move on to how do we do this. Any questions before we move on? Anything not make sense so far? Tutors all happy? All right. Wait till the next class when you have to do your little tutorials and they throw these scenarios at you. Woo! All right, Johari window comes from John and Harry, came up with a slide here, but you'll be familiar with what we also sometimes refer to as a quad slide. So it's a slide with 4 squares. Very, very simplified way of expressing something which would otherwise be complex. We do this to help us understand, but we have to use multiple different lenses. So who's heard of Rumsfeld Doctrine? Johari window, quad slide? Nobody. What are you guys teaching these people in Queensland? Down where I... All right, so known knowns, known unknowns, unknown unknowns, unknown knowns. There's a whole bunch of things that fall into these different categories. These are the ones that burn you the most. Do the dot for the camera. Known unknowns, unknown unknowns. Things you don't even know about that you don't know about versus things you know because then you can go and find them. A man by the name of David Snowden came up with a concept. He's Welsh. He came up with a concept that he calls the Carnarvon framework. Carnarvon is Welsh for habitat or the region or the ecosystem, which of course is what we're talking about. And there are 4 parts in the basic model. Anyone heard of the Carnarvon framework? 1, professor of design. Excellent. Carnarvon framework is a way of kind of helping other people understand how it works. So at the bottom corner, it was called obvious. Sometimes you'll see it now called clear because he likes to have alliteration. But whatever it's called, it's pretty much a way of saying simple. So things that are simple are in that bottom quadrant. Then we get to complicated, which of course you know about, and talks about how and why we solve complicated problems, because complicated can be solved because there is an answer. You might not have all the unknown information, but you can go and find it, or you can seek to find it if you're doing an engineering project or whatever. Then, of course, we get into complex, which we've been talking about and you'll be familiar with already. So complex systems are the ones that are constantly dynamic and changing. And then there is chaotic. Chaotic is when there is no obvious pattern to the complexity. So complexity, we can actually start to analyze and study, but when we end up with chaotic, we end up with lots of pockets. So think post-tsunami, post-disaster, natural disaster, you've got different gangs that are popping up. They're not all the same gangs. So when we're trying to influence the criminal activities, there are multiple criminal activities and it's not possible, so you've got multiple subsystems going on. Anyway, the typical way we deal with these, so the police will come in and they will establish law and order. So they will go into a rural community where there's teenage crime or alcoholism or whatever, and they'll go, right, we're going to come in and we're going to assert dominance and we are going to restore law and order in this town. Cool? Make sense? You know what I'm talking about? So they will come in and they'll impose curfews, they will stop people being allowed to buy alcohol, they'll put measures in place, self-stabilizing influences to try and bring it back to what is apparently a simple thing which they can solve. The challenge for you, ladies and gentlemen, is not to do what the police do. Asserting dominance gives a short term, it's what we call resolving as opposed to solving. It fixes it for now, but it doesn't attract the right interventions for what we call the root cause analysis. It is a short-term quick fix, long enough for other mechanisms, other infrastructure and social services to ramp up to come up with a better way of doing it. But it stops people dying or whatever. Cool. So it's a stopgap measure. It's tempting to do, but the reality is when we are wanting to do design and we're coming up with a way to fix poverty or health issues or whatever in some of these disadvantaged communities, we actually have to go the opposite direction. We have to go the other way around, and we have to go from what was obvious to what we thought was how an egg is going to get broken, and if I throw an egg at you, you're going to get egg all over you. We go into breaking down those assumptions, we start using those personas, and we start asking the questions no one else is asking. We completely remove ourselves from assumptions about how we used to do it last week, because the system has changed and what worked last week won't necessarily work this week because the system is different. But this is where we bring in co-design into disciplinarity. Anyone heard of those terms? Cool. All right, so This is where it gets a little bit more sophisticated. And the reason I personally am not a fan of the Carnarvon framework is because it's too simplistic. It looks simple. It looks like they're just 4 squares. As we talked about before, it's actually a complex system in its own right, in that those globes, those golden twin-shaped balls, constantly change. Make sense? What we've got here is a version that David Snowden came up with a few years back, which shows the depth and how other variables go. I'm not going to go into it in detail because I haven't got enough time to talk about this in depth. But I do want to suggest to you that if you haven't already, you need to go and look up the Carnarvon framework. It gets more exciting. There is more depth to it. There is more sophistication. So whilst the simple diagram of 4 quad slides looks easy to understand, when you kind of explain it to your mates, cool, but be aware that it is actually a little bit more interesting. In fact, it gets even better yet. There's a whole bunch more behind the science, and you can go to Snowden's Cognitive Edge, they renamed it Systems. Anyway, you can find them, Google them. This is his stuff, and you can do a whole bunch of cool courses. It gets really cool. This is the sort of stuff that when you go and do your PhD and that you get excited about because you start playing around in all these boxes. This has just come out in the last 2 days. This is a new variation. So understanding complex systems as a complex system in itself, and we're constantly updating, we're constantly challenging each other, and we're writing to each other, and we're going, oh, I don't agree with this, and then it changes. And then next week it'll be different again. It is very dynamic, the study of complex adaptive systems. What worked in 2025 while you were doing your final course at UQ will not be accurate in 2 years' time. When you are out in industry, you will need to stay up with the latest stuff. You will need to have a passion for learning. You will need to have a drive to constantly keep up with the latest theories and ideas. Any questions on the Carnarvon framework? So, it's like the mosh pit. Anyone heard of the mosh pit? Anyone been in the mosh pit? Come on, I know more people. Yeah, thank you. We've had one more person in the mosh pit. You've got to learn to not just survive, but thrive. Relish in the chaos of the mosh pit. Because this is where you get your epiphanies. This is where you get your ideas. This is how you start to understand the realities of a complex adaptive system. Here I say it with your adversarial. All right, how are we going for time? Do you think we need another oxygen break? How many people are brain dead? Oh, good. Okay, we'll keep going then. See, you all voted to keep going. That's good. All right, I'm going to talk about system shifting. So this is similar to shifting systems awareness or consciousness, which again, if you're doing a drone or an app on a phone or you're designing the latest handbag, cool, be aware that you still need to be aware of the system because your product will fit within a system. Here we're talking about shifting a system. So here we're talking about going into remote communities and helping some of the root cause problems that are causing poverty to be a cycle of multi-generational. Or it could be anything around the world, war zones, whatever it is, how do we crack the code on that? So we have 2 double diamond parts of the double diamond. Who has seen a double diamond methodology before? Now, if I don't see every hand up, I know you're all asleep. Come on, double diamond. Let me spell it out. All right, it is one of the foundational methods for design thinking. There are lots, and you will be exposed to many. By now, you should have been exposed to many. Has someone been exposed to a different one? No, nobody. What are they teaching you here? Nothing. You're going to graduate and you're going to say, oh yeah, I've got design thinking in my degree. Yeah, I know all about design thinking. And I'll say, explain double diamond. And you'll go, oh, I was at the dentist that day. All right, I need to start throwing more eggs, don't I? Back row. All good? So we have 2 parts. The first part is this, whoops, come over here. Over there is the sense making. We start off by understanding the system. We don't launch early. We don't go into, oh yeah, I know the problem. Oh, I already know the answer. I can already tell you my answer. I already know what I'm going to use for my assignment for this course because I already know the problem. We stop and we slow down and we back up and we have to go out and collect data. We have to explore. We have to understand. We have to use personas. We have to understand the system that we're trying to influence. And Most of us have what we call a bias for action. We just want to get on and do it. We just want that assignment submitted. We just want the grade back. Well, actually, you're not going to get the grade you want if you rush in and just already come up with a solution that you're already designing an app when you don't even actually have an idea of what the situation's like. Make sense? Who's already got their idea for their project? Not going to admit it now, are they? No. All right. So here it's just a complex adaptive system because we're observing it and we're not influencing it. When we get to the other side of the double diamond method, it starts to become a complex working because as soon as we start intervening and start shifting the systems, it changes. So who's heard of divergent convergent? Nobody on this side. You guys were all at the dentist the day they taught divergent convergent thinking. Is this true? Do they not know? Unbelievable. Right, you're all going back to first year. You're all starting your degree right at the beginning. All of those credits that you got for your coursework are now exempt, and you are starting on that. All right, let me tell you about divergent convergent. Divergent is when we explore and we look at things from a different perspective. Here we have a nice photo of Canberra, because that's where I live, across the lake. Opening of Parliament, 1927. Oh, the Duke of York was sent all the way from England to do the speech, got on a ship, sailed for 6 months. 6 months practicing the speech every day. Got to Sydney, got off the boat, got on a train that extended the train track all the way to Canberra, so right on the train, got there, went to give a speech, and of course people organising it, oh, this is pretty cool, we're going to have royalties, we're important. Let's invite the military. Military turn up, big brass band, boom, boom, boom. Oh, let's invite the Air Force. Guess what? No microphones in those days. Duke of York stands up to give a speech. Boom, 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 boom. Nobody thought about the sound and all the noise and coordinated and the Army rental in the Air Force. It was a disaster. Nobody heard that speech. 6 months he practiced that speech. And he got on the boat and went all the way home again. Because nobody stopped to go, well, what if, what if, what if, what if? So what we talk about here is divergent thinking. The committee should get together and come up with all the possible ideas. And then once they've come up with a whole bunch of ideas of how to run that ceremony, they then do the convergent thinking where they do what we call thematizing or clustering, or there's a whole bunch of words, but we reduce it down to, okay, how are we going to run this event? Just like organizing the Olympics, just like a whole bunch of other things. We brainstorm crazy ideas, then we cross out the silly ones, then we look at what are the best ones, and then we shrink it down. Make sense now? Has anyone heard of convergent, divergent now? Hey, good. All right, it gets better. There's always more, isn't there? There's always more. It's never simple with this guy. All right, we have this thing called reverging. Reverging is the bit that goes in the middle. Reverging is not as important for product design and a whole bunch of others. So if you're used to just like, oh, I'm going to build a new iPhone or a new drone or something, cool, crack on. But when we're talking complex adaptive systems, we have to look at the system from multiple angles. We need multiple different people from multiple disciplines, and we need to explore it from different directions. We need to turn the map around. We need to look for not what is obvious, patterns. We need to look for the anti-patterns. We need to ask, what are the spaces between the cases? What are the things that no one else is looking at? And so for me, I use this analogy of going around that house, flat, share house, whatever you live in, picking up all the laundry from all around the house, take it in, put it in the washing machine, and you mix it around, and you mix it around, and it goes tumbly, and then it comes out, and you fold it, and it's all very nicely put away. Make sense? That sound like your place? Oh, come on, I've got to see some sign of life. All right, somebody does washing? Anyone got a washing machine? All right, now my supervisor does not like this analogy. And for the same reason I don't like the Carnarvon framework, this itself is not good. This is not good because it is only one version of the story. We have to look at it through lots of stories. The reason she doesn't like it is because this is a known outcome. When we're looking at complex adaptive systems, we do not know what the outcome is. We haven't already got an idea in our head. But this is one little metaphor that might help. Now, here comes the fun part. This is how and why we do reverging. What's that? It's an owl. Nice. This is you guys, right? Got it? Look at it from lots of different angles and try and make sense of it. Use multiple, what we call epistemic devices, to try and make sense of the system. And then when we get on to interventions, we're doing the same thing to make sure that the interventions we're using are effective and are likely to work. So we've got sense making in the middle, we've got verification, which is that reverging. And there are two other parts that, whilst I don't want to be prescriptive about how to go about this process, there are two really important ones that should be considered. One is stakeholder engagement. Who are your stakeholders? Who are all those people who are going to be influenced by this? I refer to them as impacted entities because it's not always just a person. It might be an organization. It might be a government department. It might be a whole bunch of things, and it cascades out. And we talk about one, hot, two, hot nodes, yada, yada. You can Google those. And the other one, which is really important, and again, doesn't matter which method you use, but if you're not doing a root cause analysis, if you're not going to the heart of what the issue is that's caused the system to be in a state that we are not happy with, then you're not actually going to adjust the system to be in a state that's more favorable to you. So whatever method you use, make sure root cause analysis types are in that equation. Make sense? Any questions on that? Anyone not know what I mean by root cause analysis? It's a real issue going on here. And if we look at conflicts around the world and we ask why they've been fighting for 2,000 years, is anybody actually asking what's the real root cause to some of these issues? All right, so we'll put system sense making over there. We've got our what we call disruptive interventions. Notice I don't use the word solutions. It is not a problem that can be solved. We don't solve systems. We intervene, we have interventions, and these interventions disrupt the system to a state that is more favorable to us, because there are other actors in the system who are also influencing it and are also making interventions. And it's a constant tension between our interventions and their interventions to make it in a more favorable state. Happy with that? Got me an exam on this in the end. You ready? All right. Before we get into, and this is what I call the bow tie model, we've got a little knot in the middle. And before we come up with our interventions, we have to know what good looks like. We need to know what our ideal concept of the system should look like. Our new handbag is the #1 bestseller for the Christmas market this year. Woohoo! I don't know. What else has someone got for a thing? Our app will be the #1 app on iPhone. What else do you want to have the best of? What does good look like for you? What does your system look like in its best or most favorable system state? Noting that it's dynamic and it's constantly changing and it's what we call a transient advantage. So you might be #1 for this week, next week, but then boom, you're knocked off. What's the music kind of like? What's the latest kind of music? Spotify something? What's the #1 song on Spotify? Boom, next week it's gone. Now, how do you constantly get back to #1? So if you don't know what good looks like, you don't know how to get there, your interventions don't work. So you have to have an idea of what it's. And then we start developing our interventions to achieve what good looks like. Complex adaptive, we're just observing. Here we're starting to intervene, it changes the system. As soon as we intervene with a part to the system has changed, and we now need to come up with something else. Because as soon as we invent that better handbag, our competitors will be developing another handbag that's even better. No longer #1, and we've got to come up with a better one. And talking about the alternative futures, there are hundreds of different epistemic biases, we call them, they're techniques, methods, that influence how our system is going to do what we want it to do. So, again, not my job to teach you all of these. That's what the course is about, if they haven't already taught you a whole bunch of courses. Have you taught them yet? It's day 1, right? Day 1, okay, that'll come next week. Oh, maybe, who's done design methodologies already? Is there a course for design methodologies? Oh. Well, they teach you here up in, you guys need to come down. Oh, no, sorry. It gets more tricky, more complicated. I'm going to make slides available if you're interested, but this kind of talks about all the other little bits and pieces that go at each stage. Key thing here is the big red shaded part is where we do our innovation. This is where we do what we call the jump curve, which is leaps beyond the obvious. This is where we are the difference between our company being number one or us being number 10, number 20. It's a bit like University World Rankings. You don't stay number one all the time. You got to keep working at it. And so how and why do we come up with those interventions that no one else has thought of? Ladies and gentlemen, it has been a pleasure. The dragon awaits you. You can go out there and you can explore, you can challenge, you can question, you can take this to the next level, or you can be one of those people who go, oh, I just need the tick in the box, I just need to say I've got design in my CV so that I get the job. Doesn't matter that when the boss comes and asks me to actually do some design, I have no idea what I'm talking about. Can you do system shifting? Because anybody can make the next drone or handbag, but is it the one that stays at the top? Does anybody have any questions for me? Oh, yeah.
A bit of a personal one for you. What's been a system you've really enjoyed working on, and what was the biggest assumption?
So my biggest challenge, and I use the word challenge, not problem, is getting this known out in the wider organisation. So people like you who already have a passion for it are the easy ones. You are like the light bulb where the junk goes on the briskets. You are self-selected to come on this course because you have a passion for it. My challenge personally is how do we get those who, there's the people at the other end who are happy just turning up and, I don't know, banging in a hammer or doing whatever job which is transactional. I'm not talking about them. I'm talking about the people who have latent abilities, who have the potential to be amazing, but they haven't self-selected to come on a course like this, and they don't get the opportunity to learn it. And so for me, I have to use this methodology to say, how do we get those other people, that other percentage, to be as amazing as you guys who have chosen to do this course? And this is a technique which shouldn't, because it's a system, right? People are constantly changing. Schooling changes, universities change, so it's constantly a challenge. But yeah, there's so many topics. I work with like DFAT, for example, working in the Pacific region on how to have Australia kind of engaging more with regional partners, all sorts of stuff. Yeah, cool.
In an area where you might be trying to come up with a very specific solution, or you might think that you need to rely on more primary research as opposed to existing things, but you also have a limited time frame, like in the case of this course. What are some things you can do, like collection of new information or clever analysis of previous information that can help you come close to the same quality of conclusions as if you had a longer time frame?
Yeah, well, nice question. Right, so the bow tie model is a simplified version. What we have is actually the bow tie mesh, which is multiple of those working concurrent, because it's not a linear and you get to the end and you go off to the pub and have a drink and go, woo, we've solved it, because it's constantly changing. So you've got multiple teams coming all the way through. The reality is to learn it, we have to do what we call full walk run. So your lecturers and your tutors are going to say, for the purpose of this course, we're going to use what we call a bounded system. So draw a circle around a piece of it, and they go, we're just going to make it a little bit easier for you so that you can get the ideas, because we don't want to throw you right in the deep end. So we're not expecting you to be working at the level of DFAT, who are dealing with regional engagement and stuff, way too hard. They've got multiple teams working concurrent. So bounding the problem is the first step. The other is methodologies and techniques. But ladies and gentlemen, the best thing ever is not to just think we can turn up to the class and take notes or go away and regurgitate what the lecturer said. But you have to have a passion to go and be hungry, be curious, go beyond what is asked of you. Because that is what will make them write songs about you. Good question. Any other questions? All right, it's been a pleasure. It's a lot of fun to come up and meet some other people and see a different world and all that cool stuff. So thank you very much, UQ, for the opportunity to come up and to meet you guys. And I wish you all the best. Enjoy this course. I am jealous that I'm not doing the course, because you're going to learn a whole bunch of cool things that I need to learn. I guess I'm not allowed. Actually, I'm a UQ student. I'm doing my PhD here. That's right. I can come to your class. All right, I'll start.
Thank you, Murray, on behalf of the class. Thank you very very much. We might just, again, take a very short break before I hand you back over to